This video is intended to teach you about the three subatomic particles, as well as how to determine the number of each in an atom. Firstly, the three subatomic particle types are electrons, protons, and neutrons. Protons and neutrons are found in the nucleus, and because they are found in the nucleus, they are often referred to as nucleons. And so that is the protons plus the neutrons. We could use symbols like P for protons and N for neutrons, as well as E with a negative sign for electrons, so that we don't always have to write out the whole word for each of these particles. The electrons are found in the space surrounding the nucleus, and also different from protons and neutrons, they are much smaller. They're about 1/2000th the size, if we round, of a proton or a neutron. But they do pack a wallop because they do have a -1 charge, and they could fully cancel out, even though they're much smaller, the +1 charge of a proton. Looking at a periodic table box, there will always be 4 pieces of information provided. There will be the chemical name. The chemical name is going to be provided on all periodic tables. There's going to be the atomic number. The atomic number corresponds to not only the number of protons present within the element, but also the number of electrons that would be present in a neutral atom of that element. Next, you will see the chemical symbol provided. The chemical symbol is an abbreviation or a shorthand notation that scientists will use to represent that element. And then lastly, we will see that there's an average atomic mass provided. That average atomic mass suggests to us the approximate abundance of that element. So here is a periodic table. And so if I look at an element like boron, atomic number 5, it has those 4 basic pieces of information. I have the number 5, which tells me that I have 5 protons and 5 electrons in a neutral atom. I have the letter B, which tells me that that is the chemical symbol, the shorthand notation for the element boron. And then I also have the average atomic mass, which tells me that the most likely isotope, or the most likely form or mass of boron, is going to be approximately 11, since the average is closest to that whole number. Given a periodic table, I should be able to fill in a table like this one. This table is asking for the element name, the atomic number, protons, and electrons. And each row is going to have different unknowns. So for this first row, it tells me that I have 19 electrons. Well, in a neutral atom, there's going to be, so I'm going to write neutral atom to make sure that we are talking about a neutral atom and not an ion. In a neutral atom, the number of protons will be equal to the number of electrons. And so if we're talking about neutral atoms, if there's 19 electrons, then there's 19 protons. That's going to be true for the rest of these rows as well. So if there's 35 protons, there's going to be 35 electrons. And then the atomic number also corresponds to the number of protons. And so if I have 19 protons, then I have an atomic number of 19. If I have 35 protons, I have an atomic number of 35. And then going the reverse direction, if I have an atomic number of 10, then I must have 10 protons. And then going back to the concept of a neutral atom, if I have 10 protons, then I must have 10 electrons. To get the element symbols, which is the last part of this table, I merely have to look up the atomic numbers and match them with my periodic table. So I have atomic number 19 and atomic number 35 that need labeled. So atomic number 19 is right here. It is potassium. And atomic number 35 is right here. It is bromine. So I have K for potassium and Br for bromine. So K for atomic number 19, potassium, and Br for atomic number 35 for bromine. This table's pretty simplistic. there can be more advanced tables that will contain more information. So here we have 3 isotopes of potassium. An isotope is a variation of an element that's going to have a different number of neutrons. So just like in the previous table, as expected, we're going to have the same number of protons and electrons present for all forms of potassium. However, what we see is that the number of neutrons, 20, 21, and 22, will vary between the 3 isotopes of potassium-39, potassium-40, and potassium-41. What these numbers here are called is they are called mass numbers. So a mass number is equal to the number of protons plus neutrons in the atom. So if we look at the examples down here, like potassium-39, if we were to add up 19 plus 20, we would have 39 as our mass number. And so just like we saw up here, the mass number is 39. In the symbol for the isotope, we see that 39 show up at the top left, and then we see the atomic number show up at the bottom. And so looking at the next one, 19 plus 21, we have 40. So that's the mass number for potassium-40. And then 19 plus 22 for this third one, we have a mass number of 41. And so these are 3 different forms of potassium, 39, 40, and 41. And these not only tell us the number of protons and electrons, but also the number of neutrons present. So I can fill out a table like this one. So looking at this first row, I have the element neon. And so the first thing I could do is look at a periodic table and determine the atomic number for neon. Neon can be found in the noble gases right here. I already had it highlighted. I'll highlight it once more. So there's neon, atomic number 10. And so I could write atomic number 10 for neon. The mass number is already provided to be 22. If the atomic number is 10, then the protons and electrons in a neutral atom must also be 10. Since the mass number is equal to protons plus neutrons, I should be able to subtract 22 minus 10 and get the number of neutrons to be 12. The isotope would then be neon 22, and the symbol would be 22 in the top left, neon as the symbol, and then the atomic number would be 10.